Hello guys, welcome to the 10th video. In this video we are going to learn about a very interesting topic, BM25. Hope you enjoyed the last video for TF-IDF. So coming to BM25 ranking, this first let us understand what is BM25. So it's basically an upgrade from TF-IDF. TF-IDF is a big step. It was a big step because it gave value to rare query terms, which does give us very much better search results due to its ability to find documents which are unique, but it still has a big weakness. So, if a document repeats a matching word many times, TF-IDF continues giving weight to that repetition. So, this is one of the biggest flaws of TF-IDF and how BM25 improves it. So, BM25 BM25, what it does is two things. First is term frequency saturation, and the second is document length normalization. How it does this we are going to see just now. And so in simple words, what it does is, like, if I'm giving more weight to a word in a document, it does help, but just up to a certain point. After that, it will just keep on adding unlimited scores. So for example, you have one document with just 50 words and 4 occurrences of some word X, and you have a word of 1000 documents, and it has like 1000 words, and it has like 500 occurrences of the word, same word. But what TF-IDF would do is it will rank the second document a lot, much higher, so much that you might not even look at the first document. So this is not an ideal scenario. So this is the limitation which BM25 would help to solve. So basically, let's do a recap. What did TF-IDF do? It was frequency. In case you have not watched the TF-IDF video, it's just a video before this in the playlist. You can go and watch it. Inverse document frequency. So, for example, if you have a document and a search term, so let us just get to an example. Um, let's just create a sample example like we did for TF-IDF, in which we can show you what the result was, like what the issue was, and then we can solve it. So, BM25 demo query, sorry, query equal to, and BM25 demo documents. We have these two. For example, the query is NLP retrieval, and the demo documents, this is going to be a dictionary. So this is a document which has a lot of repetitions of the term NLP. So it will be NLP, 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 NLP. Okay, that's a lot of NLP. And in this one, you have a relevant NLP retrieval.txt, and what this has is NLP retrieval search ranking, and there is just one more document here, background retrieval.txt, and what this has is the retrieval database indexing. All right, so the expected result with BM25, sorry, first with TF-IDF, is that it will simply return us the first file which is here. So in the previous example, like system and NLP, why it was different for this example is, like, NLP is a very rare term and system is a very common term. But here, you might say that retrieval and NLP are almost have the same rarity. So you might want to give them the same amount of weight. So if I'm searching for NLP retrieval, I should actually get the document which has NLP retrieval, and not just it is not just stuffed with NLP, 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 NLP. So if I just do a demo here, PM25 demo document with TF-IDF, I can just copy this function. I can do a show demo without BM25, and this is the TF-IDF index. All right, so over here we are going to give the demo query, and this is the demo document. Let us run this. We are not going to run this. We are going to run show demo without BM25. So as I said, right, this document does rank way higher. Like you can see the score than these other documents, which might also have relevant context because it is basically stuffed with NLP. But that is not the expected top result. Our expected top result was a relevant NLP retrieval.txt. So in a way, TF-IDF is getting tricked over here when we are searching with this kind of documents because it is basically stuffed with a lot of tokens which are there in the actual query we have. Um, so coming back to BM25, it BM25 it still cares about term frequency. We need to still care about the term frequency, but it does not let term frequency grow forever. So it makes no sense to still give the same amount of keep on giving the same amount of weightage to a particular word if it keeps on appearing. So it's like the first few repetitions, let's just write it down, help, but after that each extra repetition is less valuable. This is term frequency saturation. Another thing which BM25 does is BM25 also checks the document length. How this matters is that if a document is very long, it has more chances to accidentally match query words. And BM25 normalizes this. This is document length normalization. So BM25 does these two things. Now you might ask that how does it do it? So there's actually a formula, a very popular formula we use for BM25. So BM25 formula. It might seem scary at first, but trust me, it's not that scary. It's actually really simple. So BM25 score is IDF into we can write it like this. So first there will be a TF into K1 plus 1 and okay, and this whole value I can divide it by TF plus K1 into another bracket here 1 minus b 1 minus b plus b into the document length divided by the average document length. Okay, and we have to put this whole thing in a bracket and give some space over here. So now let's go through the formula. So we have these pieces, so we can write the pieces are TF. This is how many times the term appears in the document. IDF, this says that how rare is the term across documents. We have doc length, which is basically number of tokens the in this document. We have average doc length. Let me just copy it. Average doc length. So this is the average document length in the corpus. Corpus is nothing but the set of documents that we have on which we want to perform a search operation. We have K1. It controls term frequency saturation, and we have B, which controls document length normalization. So we already know before this a normal value, like general most common value of K1 is 1.5 and the most common value of B is 0.5. You can tweak it according to our requirements. How it matters in the code, I'm going to explain it. All right. So you already know these components TF, IDF, doc length, average doc length. The new thing which is there is this K1 and B. So K1 is basically it controls the term frequency saturation. So if the K1 is higher, like if we set a higher value for K1, um, repeating a word helps for longer. So for a longer period of like for a longer length, we still consider giving score to that word if it keeps on repeating and repeating. And if K1 is lower, repeating words do not help that much in the score. So according to your basically how we tweak this is according to the data set that we have and the type of queries we are expecting. We generally tweak this, but this is the most common values for K1 and B. And what is B is basically document length normalization. So if b is 0, it completely ignores the document length, because this part it will be 0, and this whole thing it is just going to become 1, which means it's just a division of this part by this part. And if b grows and grows, like it can, the value of b it can go till 1. If it is 1, then we are fully normalizing the document length. Okay. And this is the widely used default, like 1.5 or 0.5, and actually 0.75 is a more common value. Let's just use 0.75. All right. So this was the theory. Now let's go to the code walkthrough. And for this, I need to actually, you might have already guessed, I need to build a function which calculates the BM25. So in this calculate functions, I can just do calculate def calculate BM25 IDF. This is going to take the total docs, which is going to be an integer, the document frequency, which is going to be an integer. This is going to return a float. So if the total docs, this is never going to be negative, but still let's consider that, or document frequency is less than equal to 0, just return 0.0. And just to perform a normalization, we are going to use log again. And what we are doing here is, first we are calculating this whole part. So here the bracket ends, the second bracket ends, all right. And what we need to calculate is this whole part. So um, before calculating this whole part, what we can do is we can do actually write just a function to calculate this IDF here. And so we can just do something as 1 plus, we are going to do give the total docs minus document frequency into, or yeah, this is going to be a plus 0.5, and we are going to divide this. So where does this end? So this first term, it is divided by document frequency plus 0.5, just to avoid the, the division or having 0 at the numerator. So this is the calculate BM25 IDF. Now we have the first value. Now we can give, like we can actually write a function to calculate the document length, and what it will take in is the file data. We have it here, which is nice. And just return me a dictionary like this. Return, I can do a file name is basically length of tokenized stop words for the file content, comma, stop words for file name, comma, file content in file data dot items. This is going to give me the document length. uh okay, and now we can actually build the BM25 index. So we have to write a function build BM25 index. This would take in the file data. Let's take the file data. This is going to take a k1, this is going to take a b, and this is just going to return me a dictionary of string, comma, dictionary of string, comma, float. So now this k1, it is actually a float with a default value of 1.5, and this is also a float with a default value of 0.75. Okay, and I'm going to first build the ranked index. So def ranked index equal to build ranked inverted index file data. We already covered these functions before this, so you can just see the previous video. Document length equal to, we have the function for this one as well, calculate document length file data. We can write an average document length equal to, we need to calculate the average document length. So okay, we can just write a function now, calculate average document, calculate average document length, and just give the document length, it will be just a small helper function. Total docs will be just the length of the file data. Now let's make a result, which will be the actual output of this function. So for token comma document counts in ranked index dot items idf equal to, it will be just this function which I call calculate it, and the total docs and the length of document count. So basically the value over here, document counts, and the result for this specific token, we can keep it as a dictionary. And what we can do now is that for file name comma term frequency, we are going to iterate over this document count in document count dot items. We are iterating over that. So document length will be the, this we already have it, document length, and this will be the file name. We have the file name length normalizer. You can write a length normalizer. Now let me paste the whole function. Okay, so this length normalizer, it is going to be this part 1 minus b. I can just do a 1 minus b plus b into, now we have the document length divided by the, we had this average document length, right? Just just use that, divided by the average document length. And now we have the saturated term frequency. This is going to be the first, the numerator part, so this part. And we are just going to do a term frequency into k1 plus 1 and divided by this part over here. So okay, let me see the brackets carefully, they look okay. This is going to be divided by the term frequency plus k1 into this length normalizer. So you might now understand that this is just a constant which gets calculated once and then we can reuse it again and again, even instead of calculating it for each value. And we just need to return the result token file name. It is IDF into the saturated term frequency. And here we are going to return the result. Okay, so now we have our index. Ah, so that was a big function. Okay, let me implement this as well. So we are going to do this document length. Now what is the document length? Document length is just a dictionary of string and integer. This is going to return a float, and this is just going to be hold on. Oh, okay, sorry. What are we taking in? It is the file data. uh, we are calling it on the document length, sorry, my bad. This is going to be the, yeah, it's the file data only, the file data. Okay, so length of document, so what we can do is return the basic sum of document lengths um, divided by the length of um, document lengths. Okay, this is actually going to be, no, I'm making a mistake here, my bad. So if I'm going to call this over here, and this thing, it's better if I just give it as document length, and I'm going to calculate the average, right? So this one, it is going to be this, and I can do calculate, return a sum of the document length dot values by the length of document length. And just let's just handle an edge case. If not document length, return 0.0. Okay. So we have this build BM25 index finally. Let me first build the index. For this, let me write another function which will be show it oops, with this, and we are going to build BM25 index, build BM25 index on this BM25 demo documents. I can just cut it, paste it, BM25 index, and just print the index to see it is coming properly. We can import this and call this here. So uh, when I am printing it, it gives me the file name, which is the keyword stuffed nlp.txt with the score. Hold on. Yeah, this is what I wanted. So for each token, it gives me the um, the value, like how valuable it is in each of the files. So in this keyboard stuff NLP, this NLP um, token is really valuable, much more valuable than this relevant NLP. And similarly, the retrieval is valuable in this retrieval NLP, retrieval NLP retrieval.txt, this document over here. So we need a similar function like TF-IDF to search the index we have created. We copy this one, and this is going to be a search BM25 index. This is going to take in a BM25 index, and it is going to be the same as it is returning over here. It's going to return a list of dictionary as well. So this value is going to change to BM25 index dot get tokens. And I think rest of it will be the same only because uh, nothing is going to change actually there other than just the index. I'm ranking it off as well. Let me just call this search. Let's see what comes if the result is correct. So search BM25 index. This one. Import this function. Yeah. So this is going to return. Okay. Wait. BM25 demo query. BM25 demo query. It still returns the keyword stuff NLP. Now you will see the magic here if I just remove some NLP from here. So I just remove 3 NLP of 3 or 4 NLP. Let's see how much different it brings in the score. So yeah, so you will see that the score of this keyword stuffed NLP it has dropped by a lot. And let us now play with the um, constants we had. So we have these two constants here, and what we can do now is basically if I take this, make this to 0, you will see that this background retrieval.txt it is coming at top. So the k1 value, as I said before, it actually helps me to do this first task, which is the term frequency saturation. So a lower k1 value, it does not, it like basically says that repeating a word will not help me for a longer period of time. So when I had 1.5, then I had a different score, and when I have 0, you will see that the score has dropped. So this is what I was saying, that we need to actually tweak the constants according to our use case. Like in this one, this first file is not relevant as much as the second file might be. So in this case, if I just tweak it well enough, I'm going to see that, like, I'm going to achieve the point where I have the search result optimized. And even if I do 0.3 here, and So what we see here is a score gap, which is like the 0.56 and 0.90. So this much is the gap between the first result and the second result, and this is where BM25 will help you tweak your whole pipeline. So if I want to say that I want to penalize this repeating words earlier on, what I will do is I will reduce the value of K1. So as I reduce the value, hold on, I think it did not take it. Yeah, as I reduce the value of K1, this the score of this first document, it keeps dropping. If I reduce it even further, 0.5, so you will see that the value has even dropped further. So now for our system, a value of 0.5 will be much more ideal than this previous value, because we know how the search will behave for us. This is just a small example. In the tweening, you might take a lot of queries along with a lot of documents, but generally 1.5 and 0.75, these are the most acceptable values. Like this generally work on the first when you are just starting the tuning. So I would suggest you start with this. So that's it for this video, guys. Let me just add this search BM25 in this comparison as well, so that we are consistent. So BM25 index search. This is just going to be a copy of this one. Search BM25 index, and this is going to be a BM25 index, and just build the BM25 index equal to build BM25 index along with the file details. And now run this, close this, and yeah, let me just run it again. So it it is now searching and comparing between BM25 index search and TF-IDF search. So you can actually export this search somewhere and then take a look at the results as well. So we have to end the video here. So this was all for BM25. There are some failures of BM25 as well. Like it is still a lexical search, so it actually depends on the exact word overlap. It does not understand the synonyms of the word. So for example, a word like car and automobile, these are actually very similar words, but when we, until and unless we don't add synonyms or stemming or some kind of a semantic search, even BM25 will not be able to handle this kind of thing where we want to show car when we search for automobile. So there are different search methods for this. um, BM25 does not cover this. It does not understand the intent as well with which I am searching. It just does a matching. It's a lexical search, as I say again and again. It can be affected by spam as well. For example, in the document, you have a lot of spam. And also, it does not understand negations. Like, for example, it is like you have a word like not recommended or do not recommend me. It won't understand that. It is going to instantly match the word and send you out the result. But where it shines is basically when you want to do field boost, you want to do a phrase search, you want to look for filters or maybe some semantic embeddings you want, or maybe you want to rank your data set for a hybrid search. BM25 absolutely works wonders in those cases. Just to wrap the video up, TF-IDF, it asks how frequent is this term and how rare is it. BM25 asks how frequent is the term, how rare is it, and how much is the repetition saturated, and also what is this document length, is it unusually large or not. And we also proved it by with the help of the two constants we have in BM25. So that's it for today, guys. See you in the next one.